Hello students, I, Professor Chintan Shah, welcome you all to today's lecture on disk scheduling. So in the previous lecture, we have studied the concept of buffering. In that, we have seen what is buffering, why buffering is so important, and then we have seen various buffering techniques. In that, we have seen single buffer, double buffer, and the circular buffer. So now in today's lecture we are going to see about the disk scheduling. So if we talk about the disk scheduling, over the last 40 years the increase in the speed of processor and the main memory has gone very wide. Then we compare it with that of the disk. So with processor and main memory speed increasing by about 2 times the magnitude compared to the magnitude for disk, the result happened that disks are currently at least 4 times slower than the main memory. This gap is expected to continue even in the future. So the performance of the disk storage system is of vital concern, and because of that much research is going on into a scheme for improving the performance. So in this module, that is disk scheduling, we are going to see some of the key issues, and then we are going to also see the various disk scheduling algorithm for the same. So let's get started. Before proceeding towards disk scheduling algorithm, let us understand disk performance parameters. The actual details of the disk input-output operation depends on the computer system, the operating system, and the nature of the input-output channel and the disk controller hardware. So a general timing diagram of such disk input-output transfer is as shown in the figure. So as you see in the figure, you have a seek time, rotational delay, and the data transfer time. So let us understand each one of them. So whenever the disk drive is operating, the disk is rotating at a constant speed. To read or to write, the head must be positioned at the desired track and at the beginning of the desired sector on that track. So selecting a track involves moving the head in a movable head system or electronically selecting one head on a fixed head system. So on a movable head system, the time it takes to position the head at the track is known as the seek time. So again, what is the seek time? Seek time is the time that it takes to position the head at the track. So this is the seek time. Now once the track is selected, the disk controller waits until the appropriate sector rotates to line up with the head. The time that it takes for the beginning of the sector to reach the head is called as or is known as the rotational delay. So again, what is rotational delay? Rotational delay is the time it takes for the beginning of the sector to reach the head. We call it as a rotational delay, or you can also say it as the rotational latency. So once we have understood a seek time and a rotational delay or a rotational latency, let us see what is the excess time. So excess time is nothing but the sum of the seek time and the rotational delay. So when we sum the seek time, if any, and the rotational delay, it is nothing but the excess time, which is nothing but the time that it takes to get into the position to either read or either to write. So let us understand what is the data transfer time. So once the head is there in its position, the read operation or the write operation is then performed as a sector moves under the head. So this is the data transfer portion of the operation, and the time that is required for transferring the data is called as data transfer time. Okay, so these are the various disk performance parameters.
Okay, so now let us understand the various disk scheduling algorithm. So whenever we are going to speak on disk scheduling algorithm, we have various disk scheduling algorithm. They are first in first out disk scheduling algorithm. Second, we have shortest seek time first. Then we have third type as scan algorithm, C-scan algorithm, look algorithm, and C-look algorithm. So we are going to study each one of them and how they differ from each other in detail. Okay, so here you can see the first type of disk scheduling algorithm, that is FIFO disk scheduling algorithm, or the first in first out disk scheduling algorithm. So let's get started. So whenever we say the algorithm is used is first in first out, it is the simplest form of scheduling used, where the processes items the queue in sequential order. So this strategy has the advantage of being fair because every request is honored, and the request is honored in the order in which it is received, that is first in first out. So you can see the same in the figure. So in the figure you can see the disk arm movement is done with first in first out. So as you can see, the disk accesses are in the same order as the request were originally received. So let us see the example for understanding it much more better. So in this example you can see, consider a disk queue with request for input output to block on cylinders 98, 183, 37, 122, 14, 124, 65 and 67. Okay. So now here, once you have seen this, it starts in manipulation in the form of first in first out. Okay. So now initially if you can see, the head is at position 53. So it is going to occur, or it is going to serve the request in the form of first in first out. So let's see, from the 53 the next request is 98. So from 53 it moves to 98. After 98 we have a request of 183. Okay, so from 98 it moves directly to 183. From 183 it have a request for 37. So from 183 the head moves to 37. Now from 37 there is a request for 122, so the head moves to 122. Then you can see you have a request for 14, so from 122 it moves to 14. From 14 if you can see, the next request is 124, so then it goes and serves it in 124. From 124 you can see it is 65, so it again goes back to the 65 and serves the request, and from 65 it is 67. So in this case with FIFO it is the simplest form where the process items are done from the queue in the sequential order. So this strategy has an advantage of being very fair, where it processes in sequential order. So with FIFO, if there are only a few processes that require access and if many of the requests are to be cluttered, then we can hope for a good performance. So now, since we have seen first in, first out disk scheduling algorithm, let us go to the next algorithm, which is shortest seek time first. So now you can see in shortest seek time first, as the name suggests, the shortest seek time first, which we also called it as SSTF policy, is to select the disk input output request that requires the least movement of the disk arm from its current position. Thus, we always choose to have a minimum seek time. Of course, always choosing a minimum seek time does not guarantee that the average seek time over a number of arm movements will be minimum. However, we can say that it will have a better performance than FIFO, because here in this case the arm can move in both the directions, and so it is better when we compare it with the first in, first out. So let us take an example and let us understand how shortest seek time works. So initially, if you can see, my initial head is at 53. So from 53, if you can see from the entire queue what are the requests, from 53 the nearest request which can serve, which is closest, is at cylinder 65. So if you can see, it has moved to the closest cylinder 65. From 65 there is a request at 67, which is again the nearest. So then we have gone to 67. Now from 67 we need to again find out to check which request has a minimum seek time. So the next can be either move it to the 37, or from 67, if we can see, we have to move to either 98. So as we know that from 67, 37 is closer than the 98. So better is that from 67 we go it to the 37. So let us see. So here from 67 it is moved to the 37. Now from 37 we will see which is the closest, which is nothing from the entire queue, is the 14. So here we are going to select 14. From 14 we are going to see whatever is left and whatever is the minimum seek time, that is 98. From 98 it is 122. From 122 the nearest or the shortest seek time is 124, and then from 124 the final is nothing but the 183. So this is how the shortest seek time first, where it goes and selects in such a way that a least movement of the disk arm is required from its current position. So this is how we have seen. Okay, so once we have understood the working of shortest seek time, we are going to start and understand the next disk scheduling algorithm, which is a scan algorithm. Okay, so now when we are talking about the scan algorithm, as we have seen, with scan algorithm the arm is required to move only in one direction. I'll repeat, with scan the arm is required to move in one direction only, satisfying all the requests or all the outstanding requests in that route until it reaches the last track in that direction, or until there are no more requests in that direction. Okay, so this is how it is going to work. So in the previous algorithm that we have seen, which is of shortest seek time first, we have seen that it leaves some of the request unfulfilled until the entire queue is emptied. That is, there may always be new request arriving that will be chosen before an existing request. So here we have tried to solve the problem where here we have a simple alternative that prevents this sort of starvation, which is nothing but the scan algorithm. Scan algorithm is also known as the elevator algorithm because it operates much the way an elevator works. That is, how the elevator or the lift works in one direction, when it moves to the next direction, the same way scan algorithm works. So let us try to understand the same with the help of an example. So now in this example, you can see initially my head is at 53. Now in this, the disk arm starts at one end of the disk, maybe either from my head position to extreme left or either to the extreme right. So it can move in either one of the direction till the end of the disk, till the time it reaches the end of the disk, and from then it moves to the other end, servicing all the requests that comes in between. Okay, so this is how it works. So let us take an example. So initially our head is at position number 53. So from 53 we can either go on the right hand side to complete all the requests that is coming in between, or either we can move it to the left hand side. So here we are going to fulfill all the requests on the left hand side first. So from 53 then we have 37, then as a requirement, then 14, and then it will also touch 0, that is the start. So as we have seen, it moves and completes in one direction. We have seen it started from 53 and then it has reached to 0 also. So here we are also going to consider the disk arm at 0 position. Now from there it is going to the other side to fulfill all the requests on the other side. That is initially that we started from this end, from our disk ahead to the left hand side into the extreme left, and once that is served we are going to move to the extreme right till the time our request is served. So on the right hand side we have request that is left is 67. Then if you can see, we have reached from 65 to 67, from 67 to 98, from 98 to 122, from 122 to serve the request of 124, and finally to the 183. So this is how my request is fulfilled. Now once we have understood scan algorithm, let us understand the next algorithm, which is on the lines of a scan algorithm, is C-scan algorithm, which is also called it as a circular scan, where C stands for circular, that is the circular scan. So let us go to the next slide and learn. Okay, so now this is similar to your circular scan in the previous example that we have seen. So this is another variant of a scan algorithm, which is C-scan algorithm. So like the way we used to have a working of scan, all the elevator algorithm, C-scan also works in the same fashion, but in case of C-scan, it moves the head from the end of the disk to the other, servicing the request along the way. So when we see what can be a difference between a scan algorithm and a C-scan, the C-scan, that is the circular scan, restricts scanning to only one direction. It means it starts from the head to in one of the direction, maybe to the right or to the left, but apart from the way a scan algorithm works, in case of C-scan, when the last track has been visited in one direction, the arm is returned to the opposite end of the disk, and again the scan begins. So if you can see, as I said, once it start fulfilling the request on one side, that is in one direction, once it is reached on the one direction, the arm is again returned to the opposite side, that is from, if you can see, from extreme right to the extreme left, that is returned to the opposite end of the disk, and again the scan is, and again the scan begins in the same direction. Okay, so this is the difference, right? So let us take an example to make it more clear. Now, as you can see in our request, initially our head position is at 53. From 53, it has started serving on the right hand side. So from 53, next request is 65. Next request is then 67. Next it goes to 98. After 98, it moves to 122. From the 122, it visits 124. From 124, 183. From 183, it does not stop here, but it moves till the last end, that is till the end of the disk, which is 183. Once it reaches 183, it goes, or the arm here is returned to the opposite end of the disk. That is, from 199 it moves to 0. From 0 it again start doing a scanning of whatever is left. That is, in our case, it is 14 and 37. Okay, so this is a C scan, also called as a circular scan. So if we have found out the difference, C scan and circular scan works probably in a similar fashion, but in case of C scan, once it reaches to the one end of the disk, it moves to the other end of the disk, that is, the arm is returned to the other side, and again the scan begins. Okay, so now once we are done with this, let us move to the next algorithm. So the next algorithm here is a look disk scheduling algorithm. Okay, so let us now try to understand the next type of disk scheduling algorithm, which is a look scheduling. So in look scheduling, for that we will first revise about a SAN and C scan. So in scan and C scan, we have seen that both scan and C scan move the disk arm across the full width of the disk. It means in case of SAN and C scan, we have seen that once, even after our request is fulfilled, it moves to the extreme right or the extreme left position of the disk. For example, if I have a request, say from 53 till 14, so in case of scan and C scan, once the disk moves from 53 to the location 14, then after 14 we have seen that it also reaches to the start of the disk, that is at location 0, at position 0. So again we are wasting our disk arm to move it to that location which has not been requested, that is moving from 14 to the 0th position. So in case of look scheduling, this problem has been solved. So again we are going to see as an example to make it more clear. Okay, so in look scheduling, the arm goes only as far as the final request is served in each direction, instead of going to the extreme end position, that is the start of the disk or the end of the disk. So in case of look scheduling, the arm goes only as far as the final request is served in each direction, and then it reverses without going all the way to the end of the disk. Okay, so this version of scan algorithm is called as look algorithm, and C scan is called as C look algorithm. So initially, as given, head is at position 53. From 52 is going to serve a request in one direction, that is 65, then 67, 98, 122, 124, 183 in one line. But then instead of going it to 199 as it was there with the case of C scan, it is C look moves in the direction till the time a request is served. So in case of C scan, it has stopped it in position number 183. From 183, our next request is 14. So instead of going from 183 again to the position that is the starting of a disk, it is better to go to the one which has been requested, that is from 183 it has moved to the 14 and again it continues. So this is an example of C-look algorithm. So the way we have understood C-scan, this is similar to C-look. So the only difference in case of C-scan and C-look is that it does not touches the extreme end of the disk, that is the start of the disk and end of the disk. Similarly, we have a scan algorithm which is similar to the look algorithm. Okay. Okay. So since we have understood all the algorithm, disk scheduling algorithm, that is first in first out, then we have seen shortest seek time first, then we started with scan algorithm, then we have seen C-scan or the circular scan algorithm, then we went it to a look algorithm and a C-look algorithm.